Right then, hopefully by now you've learnt what voltage is, what current is, what resistance is, and how they're related. So now we're going to have a look at power. Now, particularly with electric vehicles, it's important to understand what these terms mean. Power we measure in watts. It was named after Alexander James Watt, who very kindly named the unit of power after himself. Very selfless act. So it's the capital W because it's his name. Top trivia. And it's the rate of doing work. Power is how quickly you get a job done. So it's the same for mechanical power or electrical power. If you imagine a car driving up a steep hill, then the work it's doing is going from down there to up there. That's the work that it has to do. Now you can do that with a low power engine driving very slowly, or a high power engine driving very quickly. So it's how quickly you get that job done. That's what power actually is. So the rate of doing work measured in electrical terms turns out that if you times the current in amps by the voltage in volts, you get the power in watts. How convenient is that? That's very easy to do, isn't it? And it can be quite useful. So for instance, if we were trying to design an auxiliary lighting circuit, you want to stick a couple of driving lamps on the front of your rally car, and you want to know how much current it's going to pull and therefore what size cable to use and what fuse to use. Then we can simply have a look at this and say, well, the current has got to be the power divided by the voltage. So you know what power lights you've bought, you know what voltage you're running them at, so you can work out the current. That's quite a handy thing to be able to do. So power, the rate of doing work, how quickly you get a job done. Current times voltage. Now, with electric vehicles, this is particularly important because one of the problems we get is that when there's a lot of current flowing down a conductor, you get losses in there. Everything has got a little tiny bit of resistance. Even a wire doesn't have a lot of resistance, but there's a little bit there. And when there's a lot of current flowing down that wire, you'll lose some of that energy as heat, and that cable gets slightly warmer. And the more current goes down it, the warmer it will get, and that's a loss. That's an inefficiency, so we want to minimize that. So you can see that if we want a certain amount of power, say we want a 100 kilowatt motor, then if we want to minimize the current and make that as small as possible, then we're going to make the voltage as big as possible to compensate. And that's why electric vehicles are running higher and higher voltages. And we're going to see a lot of vehicles going up to about the 800 volt mark. They won't go much above that for a while because there's lots of complicated things that happen when you get above 1000 volts. But that's the direction of travel. It's a very useful way of minimizing the amount of current by increasing the voltage and making everything work at that higher voltage. That way you get less losses through all the cables, less losses in the motor as well, to be fair, and it all works a bit better. So power, the rate of doing work in watts is the current times the voltage. Nice and easy one, that. All good so far? Following it? Love it. See you next time.